Welcome back, students. Today we're going to be talking about solving absolute value inequalities. So an absolute value inequality is an inequality that contains an absolute value expression. For example, if absolute value of x is less than 2 and absolute value of x are greater than 2 are absolute value inequalities. An important thing to remember about absolute value is that the absolute value represents the distance from 0. So this statement right here, absolute value of x equals 2, means that we're saying there's a number that is 2 away from 0. Well, that could actually be two different numbers, either -2 or +2. So this means the distance between x and 0 is 2. Now that can either go in the positive direction or the negative direction. X has two different answers there. When we're dealing with inequalities, here's how it's going to look. First example, we've got the absolute value of x is less than 2. Now what that means is that the distance between x and 0. So think of absolute value that way. This is the distance between x and 0 is less than 2. So think of all the numbers that are less than 2 away from 0. And you'll notice that's exactly what's graphed right here. All of the shaded region is the space that is less than 2 away from 0. That space is representative of the two inequalities, of the compound inequality, x is greater than -2 and x is less than 2. Some things to notice about this compound inequality down here. Notice how similar it is to the absolute value inequality. In the one on the right, notice it's basically the exact same inequality, just the absolute value got taken off. With the one on the left, there is a bit of a change. We took off the absolute value inequality, we changed from less than to greater than, and we took the +2 and we changed it to a negative. Okay, keep that pattern in mind because that pattern is going to repeat a lot, and you being able to see it is going to help you in this work. Next, we've got if absolute value of x is greater than 2. Remember what absolute value means. The distance between x and 0 has to be greater than 2. So think of all numbers that are more than 2 away from 0. We've got numbers like 3, 4, and 5. But also -3, -4, -5. Those numbers are also more than 2 away from 0. So the graph of the absolute value of x is greater than 2 is really the graph of the compound inequality where x is less than -2, because anything less than a -2 is going to be more than 2 away from 0, or x is greater than 2. Now, another key thing to notice, when our absolute value was less than, it was combined using the word and, because the distance between x and 0 had to be less than a certain number. So we're going to stay confined in being close to 0. However, when the distance between x and 0 was greater than a 2, that took us off in two different directions. So we use the word or. So when the absolute value is less than, and. When the absolute value is greater than, we use the word or. Which is basically what this next part is going to show. If I wanted to solve this inequality, this absolute value inequality, I need to do it by creating a compound inequality. Because this is less than, that means I'm going to combine these two with and. Notice over here on the right, it's the same exact inequality. The only difference is we took off the absolute value. With this one on the left, it starts the same except for the absolute value is gone, but we changed the inequality symbol and we changed C to a negative. In this next one, the big difference is this one is greater than C. So in order to create this compound inequality, we're going to combine it with or, because we had a greater than symbol here. So in the one on the right, notice written exactly the same, just no absolute value. One on the left, we took off the absolute value, we changed the inequality, and then we changed C to a negative. The other thing to notice with this is that in both situations, it talks about C is greater than 0. That is going to be important, so make sure you pay attention to that. I'll explain later why that's important, and we'll see an example. Now, in all of these inequalities, we could replace the less than with a less than or equals to, or a greater than with a greater than or equals to. And when we graph it, it's going to make the difference of going from empty dots to filled in dots. All right, so we've got two examples here. In this first one, first thing I'm looking at, I notice this is the absolute value is less than the 2. So as I rewrite it, I'm going to combine them with and. I've rewritten this one exactly the same, just no absolute value. And this one took off the absolute value, switched the inequality, changed the number to a negative. Okay, and so now in solving it, let me just focus over here on the right. I'm adding the set on the left. I'm adding the 7. So I'll subtract 7 from both sides. Now, since both of them had an x plus 7, I'm basically going to do the same exact steps with both. That leaves me with x is less than or equal to -5, and x is greater than a -9. So I have to be lower than the -5, but higher than the -9 to graph that. Now notice it was or equals to, so we're using filled in dots. From -9, we'd go greater. From -5, we'd go less than. The intersection is right in between the two. All right, so now solving the next one. Once again, it was less than, so I'm combining using the word and. The first one didn't change except for removing the absolute value. In the one on the right, removed the absolute value, flipped the inequality, and I changed that 0 to a -0, which basically didn't do anything. But notice what this is saying. Now, earlier I had stated that C has to be greater than 0. Now here it's not greater than 0, it's actually 0. But think about what this is saying. This 8x minus 11, whatever number it is, has to be less than 0. But it also has to be greater than 0. So it has to be negative and positive. Well, there's no number that's like that, which means that there is no solution here. This would be impossible. When we start having that C value, that value where 0 is, being 0 or less than 0, we create situations that are sometimes impossible, especially when we're dealing with it being less than the 0. Or you can also think of this, an absolute value is always a positive number. So how can this positive number be less than 0? It creates a problem. All right, so now we're going to solve a few more. Starting right over here, we got greater than this time. Because it says greater than, we're going to be combining them using the word or. We got -1. We'll add 1 to both sides. So then C equals 6, or C is greater than or equal to 6, or C is less than or equal to -4. So to graph that, draw our number line. First we'll graph the C is greater than 6. Then we'll graph C is less than or equal to -4. And we're done. We've successfully solved and graphed that absolute value inequality. Now in this next one, notice once again, the C is not greater than 0. This time we started with a negative. That creates a unique problem here. Now notice all this is saying is that we have to be greater than a -2. Well, since the absolute value always yields a positive result, then that means that no matter what we change m to, this will come out as a positive number. And all positive numbers would be greater than the -2. So in this situation, rather than there being no solution, basically any number you put in would work. Every number in the universe is a solution to that particular inequality. All right, final one. We're dealing with less than. So the absolute value is less than means we're going to combine these with and. The first inequality I wrote, exactly the same. We just took off the absolute value. The second one, took off the absolute value, flipped the inequality, changed the number to a negative. And now we can begin solving. We'll add a 1 to both sides. That'll give us 2w is less than 12 and 2w is greater than -10. Now we're going to divide by 2 and we get w is less than 6 and w is greater than -5. So that combination, we have to be less than the 6 and greater than a -5 to make the graph. We put a dot at the 6. Remember, we need to be lower than the 6. Dot at the -5. We need to be greater than the -5. And there's our intersection between the two. Now, absolute deviation. Absolute deviation of a number x from a given value is the absolute value of the difference of x and that given value. Now, this is just to say how far away some number is from another. Now, when we are just asking about how far away are these two, if I asked how far away is 5 and 2, I can do 2 minus 5 and say, oh, they're -3 apart. But that doesn't make any sense to say that something is -3 distance. And so that's why we have this absolute value. It tells us absolutely how far away they are. And so even if I did 2 minus 5 equals -3, because I'd have it in the absolute value, that would tell me that the absolute deviation was 3. Or in other words, 2 and 5 are 3 apart. Now, let's look at a real-world application of this. You're buying a new computer. The table shows the prices of computers in a store advertisement. Now, you're going to be willing to pay the mean price with an absolute deviation of at most 100. So mean price, think of it like the average price of a computer. So you've looked at all these different computers. Here are the prices there. You're not looking for top market computer, but you also don't want a junker. You don't want something you're going to have to throw away next year. So you'd like something that's about average, and you're willing to spend with a deviation of $100. That means you're willing to go $100 below the average and $100 above the average. The reason you might want to do that is because if you spend too little on a computer, you're probably going to get a junker. If you spend too much, you're probably getting more performance than what you actually need for the way you use it, or you're spending too much money. Okay, so we want to be right there in the middle, and we don't want to go too much below or above. So first thing I want to focus in on is that mean. We want to find what the average computer price is. To find the mean, you add up all the numbers, divide by how many there were. So the average cost of a computer that after you looked at all these different computers in a store advertisement, was $664. So now that we know the mean, we want to be at an absolute deviation of 100 away from that, so 100 or less. So here's how we write that. This absolute value right here is our absolute deviation, x minus the 664, and we want our deviation to be less than 100 away from that average cost. All right, so to solve this, we're going to create our compound inequality. We are using the absolute value as less than, so we combine it with the word and. Our first inequality we just took off the absolute value. The second inequality took off the absolute value, flipped the inequality, changed the 100 to a negative. Now we're going to solve both of these by adding a 664 to both sides. So we get x is less than or equal to 764 and x is greater than or equal to 564. So on this computer, we could spend anywhere between $564 and $764, but we don't want to go below or above that range. Well, I hope this has helped you. Good luck on your homework.